years or whatever is of interest for you. So there's also a graphical representation. In this plot you see point data and then continuous but interrupted time series and so forth. You have the t-axis there, and you get something out, and you can see if your time series is complete or not. And this is particularly interesting if you are dealing with millions of points, for example, or a long time series. This plot here shows chlorophyll versus time. This is close to the, let's say, on the southern hemisphere MODIS observations, and they have been analyzed to see how the chlorophyll evolves there over the various years. And this is a plot I have done, I will show next, about MODIS land surface temperature reconstruction we have been doing. Before doing so, a few words about visualization, something you have already seen. There's a new animation tool included in Grass GIS7. You see this LiDAR time series has been animated. It comes from a multi-annual time series observations being done in Northern Carolina, the coastline. These data are publicly available. In Portland, last year we gave a workshop on that, and you can search for this data set and do the exercises yourself, so it's pretty easy to get something like this. And you can see how this is a dune, how this dune is moving over time because it's transported, let's say there's the sand transport by wind, and you see also houses being built up and even disappear because they get probably destructed by some bad weather event and so forth. Then for another point of multi-temporal data analysis, if you have, this is the tsunami event in Japan in 2011, you can see for disaster management before and after event have a slider and can visually compare what happened to get an idea about the graphical, about the impact in a graphical way. Volumes I have already shown. How to look into a volume is not so easy, so there are two options. One is to make slices in any direction, which you can see over there. And another option is to get a semi-transparent visualization of your volume content. And this is another possibility, and you can then move around. And if you have a kind of theater, like here in North Carolina, where much of this part, this is Helena Mitasova, much of the part has been developed, you can get the coastline visualization really something like real. Here's Anna Petrashova. She was developing this visualization tool. Okay, connecting to other software, which is quite of interest. Also, Grass has been added to the processing toolbox. I don't want to go into detail. Many of you will know that. We have updated the toolbox to Grass 7, so I think in the next release there will be a Grass 7 entry as well, so that you can go for that. Published only, I think, 24 hours ago, the SP Grass 7 extension for R. So you can now directly connect Grass and R as before, but now with the new Grass 7 version. I just made some plots, elevation versus geological classes. You get over your data into the R space. Raster vector is both supported, and you get out your box plot, and that's all. No, so like this, you can really do sophisticated statistics in no time. New in 7 is the WPS support. So if you want to define WPS processes, the different software packages supporting Grass 7, the Zoo project, PyWPS, and 52 North, all of them come with Grass providers. Maybe there are more, I don't know. And the interesting part is that each command can express itself in this XML style here. So, and this also applies to your own script. So if you write a script and you make use of the standard parser command, you just clone an existing script. That's pretty easy to set up. Now it would also spit out this kind of information here, which you can then integrate in your workflow. So programming, we have, oh no, sorry, this before, this is just a quick view what you can do. You don't really want to import your data always, because this also duplicates space, and if you space occupation. And if you have something like 1 terabyte and you would import it and get another terabyte of space consumption, that's not that fun. And for this, we have a command called r.external or v.external as well. and you just register the external data set, could be a GeoTIFF or whatever, in your grass location, which you can automatically create from the original data set as well. And then you define as output you want GeoTIFF back, which means at this point you say the original data set is there, you don't import it, you just tell grass where it is, and you tell everything which is calculated would be saved as GeoTIFF in this case. And then you do your computation, rmapcalc, and you can see here I put the ending newmap.tiff is equal some function, and this will be immediately appear as a GeoTIFF in the directory which I have specified here. So you don't bother anymore with the import-export, but especially interesting for WPS, you just go through and get your GeoTIFF or whatever format you prefer out, and then you seize the connection and you can make use of it. So programming. There's a new Python API, which I don't show here because this is being shown in the next talk. So just stay in the room, and you can also grab the slides, I think, later on from the website. And now some words about the massive data support. What's massive? Just quickly, you know this probably. Limiting factors are memory. And limiting factors can be processing time if you have lots of data. Disk space is something which is nowadays I would consider more or less solved in a period of terabytes and going towards petabyte maybe. And largest support file size is also no longer an issue. What's an issue is, and what can be solved in the software itself, this applies generally to any software obviously, make it faster. And here's an example of a query. How much time it takes if you increase the number of points, here 1 million points, for example, you have a LiDAR point cloud, and you want to query something within 10 million points, it should be fast. And you can see the difference between 6 and 7 is that it is really fast, and this due to a new format which has been implemented. So the Grass vector engine has been quite improved, and you can also easily upgrade between both formats. There are scripts for that. Computational time in the raster world is a cost surface calculation. In Grass 6 you have this nonlinear growth of time consumption, which has been turned into a linear problem, and this is something quite better. Yes, you see my small laptop here, so this is nothing fancy, but I can do a PCA, so that is a principal component analysis of 30 million points in what did I write, 6 seconds on this machine. So try this in some other software, and I think it will take a little bit more of time. So what we have done, we have been using a MODIS land surface temperature data. So this is now an example for a large data set. These are 20 tiles of land surface temperature of MODIS, and those are being, if you want to just move there to see more, no problem for me. So this is Europe. You can hardly see it. This is one particular overpass. It has been cloud contaminated, and what we wanted to do to reconstruct the values which are not there. And this is a fairly complex algorithm which we have been publishing in this paper here. And from there to there, everything is done. So outlier detection, multiple regression. Also multiple regression is now implemented in Grass 7. And you eventually get out this map. So it looks like magic to come from here to there, but what we do is we do not consider only this single map, but we look back and forth and give a weight. The closer we are to the observation itself, the more weight we give, and the further we go on, the less we do. So maybe the day before, the day after was not cloudy in this particular pixel, and we also assume, of course, that seasons do not rapidly change. So this is something which is naturally to be considered here. So this is an example, one map out of 17,000 maps at time. So we have been processing the entire archive of Europe, or covering Europe. Each map is having something like 450 million pixels. And to construct, or let's say calculate this map, we have 9 different input maps. So we are multiplying this 0.9, we are almost close to over 4 billion pixels at this point. And this is something which you can now easily do in Grass 7. In 6, forget it. So in 7, you can do that. And this is now the animation of monthly averages out of these 17,000 maps, right? So this is approximately, including the average data, 20 terabyte or so, which we have been generating. We used our cluster for this. Due to lack of time, I don't speak about the technical stuff too much, but just to give you an idea what HPC could be. I mean, this is what we have been setting up, and maybe I would be happy to discuss this if you are doing similar things. Yesterday there was a talk about cluster file system, so we're also using cluster file system here, having small low-cost boxes. Each of them contains 4 disks of 3 terabytes, so this part here is already something like 96 terabyte for the raw data storage, and then we have all the chassis here connected to the front-end node, and using a job manager we are doing the computation here. And then we have 2 high-speed devices as well for the Grass data management and so on. So if you are interested, we can discuss. Some big data challenges we had, so this is something I'm doing for many years. Meanwhile, we always had the problem to saturate connections, like saturating the internal 10 gigabit connection, for example, tuning the internal TCP protocol for that. Then we exceeded the X3 specifications, so we switched to XFS. We exceeded the XFS specifications and so forth. Now this is something, the more data you get, and this is naturally a problem also for the new Sentinel data processing. I think things changed a bit 10 years ago. You hardly, or maybe 15, you hardly got data. Now we are almost swamped by data, which is a nice problem. Now, and we need to get our hardware and software right. Well, and so on. And this is something which was a nice benchmark for us in order to see if Grass can handle this kind of data. And we would say we can do so now. I already mentioned, if you then run the project, the computations in parallel, having something like 4 billion points in one job, but then you launch, let's say, a few of them in parallel, then you really know if your I/O works or not. So where's the stuff? Everything is ready to use. We are currently at the release candidate number 1. So probably next, what is today, Sunday. So in 2 or 3 days, we will release the next release candidate, and this is hopefully also the last one. You get free sample data to play with. Also the time series, which I've already mentioned, so that you can explore easily, including tutorial, by the way, exploring easily climate data analysis or LiDAR time series, which not everybody has at home. You can just download from there and figure out the new features on this dedicated page here, which is also linked everywhere. And well, you're welcome to test it out if you don't do so. If you are a user of Grass 6, please consider to upgrade rather sooner than later. Thank you.